Hello everyone. Today I would like to discuss the S.O.L.I.D principles. The acronym S.O.L.I.D was proposed by Robert Martin, the author of several books in the widely known developer community. The S.O.L.I.D principles were first introduced in 2000 in the article Design Principles and Design Patterns by Robert Martin, also known as Uncle Bob. These are principles to follow when developing software in object-oriented programming. What are these principles? Formally, they are stated as follows. I stands for the single responsibility principle. The next letter O refers to the so-called open/closed principle. L is the Liskov substitution principle, named after Barbara Liskov. Next is interface segregation. And finally, the last one is dependency inversion. These are quite interesting names. And of course, we need to understand what lies behind each of these definitions. But before we delve into their discussion, I will say a few words about these S.O.L.I.D principles. In short, these principles help us to properly and effectively construct the architecture of a program so that in the future we can easily extend and modify it. It should be modular and easily understandable, meaning readable. And of course, when we apply these principles, it is assumed that we are developing a somewhat complex project. If our program has only 2 to 3 classes, then these S.O.L.I.D principles are not really necessary. Although, to be honest, they are certainly needed. However, in some cases, you can comfortably disregard some of them. What we are going to talk about now is the development of more or less complex and large projects, where you might have 10, 20, or 100 different classes. So let's engage our imagination during the examples, because we certainly won't be creating such a large program. In the future, these classes may be endowed with new features, existing classes may interact with the new classes, and the functionality of the already existing project will be expanded. Our main goal when developing such more or less complex projects is to modify the previously created code as little as possible, while still being able to extend its functionality by adding new features. In order to achieve this, it is necessary to carefully consider the architecture of the program. This, of course, is not easy. It is clear that no one in their right mind would expect a young specialist to create a perfect architecture, but there is always something to strive for. And this is where the S.O.L.I.D principles come in handy. It is worth noting that these are not strict rules, but rather recommendations on how to proceed. When developing a project, it is essential to adhere to these principles to achieve the desired software architecture. This means creating programs that will require minimal modifications in the future. We do it once, test it, and in the future, if something needs to be added, we would simply do it by adding new classes. One could say that these are somewhat like 5 commandments that would be good to adhere to. And of course, if you have a small project, it is very unlikely that you will use all 5 principles. I think you generally understand what this is about. So let's move on to the first principle. Single responsibility. The single responsibility principle states that each class or method in the development of a project should perform a strictly defined function. That is, to be limited only to its task. There is no need to create classes overloaded with various functionalities and turn them into a sort of combine. There should be no such divine objects in the program. The main goal of this principle is to decompose a class or method. Remember, during your studies, when you needed to solve a specific problem, your instructors surely told you to decompose the problem and solve it gradually. But who listened to them before? In an ideal world, one entity would have one task, but not always one method. Let's imagine that we have a class called Message. We created it, and let's say it has several fields. Let's assume the field, text the field, type will be author and the indicator. New message about enhancement. Let's create a constructor for our project, a completely empty one. But just in case, let's make it complete. And probably, we will certainly right away override the toString method. Of course, we will have some methods to work with this class. Creating a message. He accepts the author and the text. Excellent. He accepts the author text. Some logic. We have this purely as an example. And let's say we also have message saving. Just some class with fields, a constructor, and some methods. The toString method is overridden, nothing new. We have a method for saving. But let's say that in a week the requirements change, and you need to save messages in different databases. And in a week, you might need to create a method for generating some notifications, for sending those notifications, for logging, and so on. And of course, you will create all these methods here. Everything seems fine. We have everything related to messages in one place. However, in the end, this class can consist of hundreds of lines. The logic will become mixed in these methods, and sooner or later, this will lead to errors. When adding new functionality, you will likely have to rewrite a lot of code. But what if we separate the functionality into different classes? For example, saving messages. Today, you need to save messages, for example, in a basic SQL database, and later also duplicate them in Postgres. If you extract this functionality into a separate class, it will take much less time. Let's create a class or release a repository. and we will develop a new method saved to MySQL. It takes our message and let it simply output it in our system. And similarly, let it save to the H2 database. Now we can remove it from our main class. Everything relates to persistence, but we have a separate repository that specifically handles persistence. If you need to add saving to a new database or to the cloud, we can simply write a new method without changing anything in the class. If you join a new project, you find a repository class and understand that it is likely responsible for persistence. You add a new method and everything works. It also allows multiple developers to work in parallel on different functionalities. One for saving, one for sending, and so on. All of this can be in different classes. Using it is, of course, also simple. We have message, and we are making repository. We access it through the repository, for example, with H2. That's it. The usage is extremely simple. How do you determine what one class should do and what another should do? This is a question of architectural art. Of course, it heavily depends on the project, but in any case, it is clear that responsibilities need to be divided among classes. Next is the open/closed principle. This principle states that classes should be closed for modification but open for extension. Of course, we do not live in a perfect world, and there will be situations when we have to modify existing classes, for example, to fix bugs. But remember, we are not talking about strict rules, only about principles. Therefore, it is advisable to avoid changing an existing class whenever possible. It is better to use abstractions and interfaces. If we ask GPT or look up a bunch of other examples on the internet for this principle, we will surely come across examples involving geometric shapes. But today we won't repeat ourselves, and I hope this example will be clear to you as well. Let's return to our repository class. He violates this principle, but why? Because if we want to add new functionality, for example, to save an object to the cloud, we will have to add a new method. And this is bad, as we will have to modify an already written class. And you remember that according to the open/closed principle, the model should be extended, not modified. Here we will need polymorphism and abstraction. We can get out of this situation by using interfaces and sets of classes that will perform their specific functionality. One class for saving to disk, one class for the database connection, one for the cloud, and so on. This approach will allow us to modify the program without changing the existing code. We can do it this way. Fix this repository class, which, to be fair, does a lot of things, even though it seems to comply with the first principle, the single responsibility principle, as it is only responsible for saving. We will create an interface and call it, for example, saver interface. This will be a simple interface, and we only need to define one method, which must be overridden in the child classes. The method is simple, save, with some further logic of its own. Now our repository class implements the interface. He will certainly highlight it in red because we need to implement the save method. Now we will extract these methods from here. Of course, we need to rename this class. He will now be narrowly focused, saving the H2 database. That's it. Now we are writing some of our own logic here that we will specifically save in the H2 database. In the panel, we can easily and efficiently create another class specifically designed for storing basic MySQL data. It will also seamlessly implement our predefined interface with some of its own logic, but we will conditionally denote this logic as self. In the end, we have two independent classes. If you need to save a message, for example, to the cloud, you can simply add a new class that implements our interface without changing the previously written code. This implements the open/closed principle. There is no need to modify old classes to add new functionality. We add new functionality by overriding the save method defined in the save interface. Working with these interfaces is straightforward. We select the necessary classes for storage as a parameter. Oops, if we forgot to specify, a message is waiting for us. We should run it. Well, of course, everything will work, because actually, there isn't much functionality here. But we see the save to too. Also, using polymorphism, it can be written this way, and similarly for the second one. Either way, that's correct. Use whatever is more convenient for you. So, in the end, our program is easily extensible for saving objects to various storage systems, while implementing the open/closed principle. By using polymorphism, a variable of type save interface can refer to any subclass. Here, we used interfaces and polymorphism to implement the open/closed principle. The Liskov substitution principle as formulated by Robert Martin, states that functions that use a base type should be able to use subtypes of that base type without knowing it. This literally means that when building an inheritance hierarchy, the created subclasses must correctly implement the behavior of the base type. That is, if a base type implements a certain behavior, then this behavior must be correctly implemented for all of its descendants. If we call any method of the base class to a derived class, we should expect the same behavior as if we had called it directly from the base class, meaning it should not change significantly. Let's look at an example of how this principle is used. So, in our message class, we have createMessage. It processes the author and the text. Let's create another subclass of the message class. We'll call it, for example, newMessage. This will inherit from the main message class. We will create a similar method for it, but with some minor changes. He will also change the boolean. We want this subclass to work exactly like that. I don't know why, but we really want this. Now, when we call the createMessage method, it will set the status to true. In this case, while nothing changes in the base class, we know that by default the boolean is set to false. As a result, our derived class violates the Liskov principle. But why does it violate it? Because the behavior of the createMessage method has changed. If we call it from the base class, author text. Let's create a new one. It seems someone forgot to do the S.O.L.I.D, and we will output them to the screen. We see that we have the first false and the second logically true. One could say that, to some extent, the behavior of the method has changed. Quite drastically, because most likely, the work of other methods will depend on the logic of this boolean from new. Once again, this principle shows that derived classes must provide exactly the same functionality as the base classes without altering it. Through derived classes, one can only extend functionality, not change it. In fact, this is the Liskov substitution principle. I hope you understand what this means. I would like to remind you that these are merely recommendations, not strict rules. If the task requires it, you can certainly bypass them, but in most cases, it is better to adhere to them. The next principle is the interface segregation principle. The principle, as stated by Robert Martin, declares that clients, which are software entities, should not depend on the methods they use. That is, if a method of an interface is not used by the client, then changing that method should not require changes to the client code. Adhering to this principle involves creating interfaces that are specific. Only the necessary minimum of method implementations. Excessive interfaces, on the other hand, can require the implementing class to create a large number of methods, including those that are meaningless for that class. In some ways, the interface segregation principle resonates with the single responsibility principle. Interfaces should not be overly large. If an application suddenly has a very large interface, there is a high likelihood that this is due to having too many different responsibilities within that interface. Therefore, it makes the most sense to decompose this interface into several simpler ones. Of course, let's take a look at this in code. Imagine that we have messages and notifications in our code. Let's create a separate class for them. We also have an interface that is responsible for sending messages. He has certain methods, sending via email, phone, WhatsApp, and Facebook. And we want to use this interface in the message class and in the notification class. But the nuance is that we need to send the message only to the phone and email, while notifications go to WhatsApp and Facebook. I don't know why it has to be this way, but that's the virtual task. But if we implement the interface in notifications, we will have to override all the methods. We don't need all of them. In fact, the interface segregation principle states just that. Therefore, we simply need to split our interface into two new ones, and use only the necessary part in the new class. It will look something like this in my sender. We will remove the unnecessary parts. Here too, we will remove the unnecessary parts. And let's simply create a new interface, a sender for messages. And it will have the methods that are absolutely essential and needed right here, in this particular section. Here we will be able to implement only the interface that we need and nothing more. Let's implement these methods. For WhatsApp, Facebook, we have our own rules here, our own way. In my opinion, this is the most understandable and logical principle. Divide and conquer. The dependency inversion principle. The last principle of object-oriented programming and design formulated by Robert Martin. The principle states that high-level modules should not depend on low-level modules, but both types of modules should depend only on abstractions, Abstractions themselves should not depend on details, but details should depend on abstractions. Oh, these definitions, they can bring you to tears. Let's consider an imaginary payment system for processing payments through various methods. We want to create a system that can handle various payment methods, such as credit cards and PayPal. Here is an example that violates the dependency inversion principle. What do we have here? A class for credit card payments, a class for PayPal payments. We have our main payment handler, payment processor. We pass two fields here, credit card and PayPal, and then we use them. What is the problem here? Our payment processor class directly depends on two specific classes, credit card payment and PayPal payment. This makes it not only difficult to extend, for example, when adding new payment methods, but also contradicts the dependency inversion principle. Let's see how a proper implementation would look. We have a common interface, which is payment method, that defines the pay method. Great. We have an implementation of this interface for credit cards and an implementation of this method for payment through PayPal, and actually our patron processor. What is the advantage of this implementation? The payment processor depends on the payment method interface, rather than on specific payment implementations, as was the case in the previous example. Flexibility. We can easily add new payment methods by simply implementing the payment method interface, without changing the logic of the payment processor. Modularity. The payment processor class becomes more modular, as it can be used with any payment method that implements the interface. In the future, if we need to add a new payment method, such as Apple Pay, we will simply create a new class that implements the payment method interface, without changing the existing payment processor code. Essentially, this is embedded in the fifth principle of dependency inversion. You can pause and take a closer look at this example. That's really all there is to the S.O.L.I.D principles. I remind you that these are just recommendations. You don't have to strictly adhere to every principle when developing each of your programs. They serve as guidelines to ensure that the programs ultimately end up being modular, scalable, and readable. And this is the main focus of the S.O.L.I.D principles. That's all for today. If you have any questions, feel free to leave them in the comments. Thank you for your attention. Goodbye.